All right, so we're going to move into section 2 of unit 3, which is going to deal with learning targets 4 through 8, I believe, on your learning target sheet. I have to double check that, but that's what I have written down. All right, so building off of the idea we talked about in section 1, which was energy and temperature kinetic energy. So energy and the change of state. So the identity of a substance does not change during a change of state, but the energy of a substance does. Think back to unit 2, we talked about physical and chemical changes. Okay, so melting or freezing or boiling point, all those were physical changes because we weren't necessarily changing the identity of that substance, we were just changing its state of matter. So that's important to understand here and remember, and now we're going to take it a step further about that really what's changing is the amount of energy within that substance. So if energy is added to a substance, the particles are going to move faster. If energy is removed, the particles are going to move slower. So as particles move faster, then you'll move from solids to liquids and liquids to gases. Okay, remember, gases have the highest amount of energy in their substance. And the opposite is true. If you remove energy, then you'll move all the way from gases to liquids to solids. Solids have the least amount of energy in their particles. When enough energy is added or removed, a change in state will occur. So a change in state is going from a solid to a liquid to a gas to a liquid to a solid to a gas, or a gas to a solid. So changes in state that require energy. So these are the changes in state that require energy to be put into the substance. So evaporation is a change of state from a liquid to a gas. An example is boiling. Sublimation, a change of state from a solid to a gas, directly skipping the liquid stage. So the best example of this is dry ice. Dry ice doesn't necessarily melt, it just turns into an ice, or a gas, I'm sorry. Melting changes the state from a solid to a liquid. An example of this is ice. So changes in state that release energy. Condensation is a change of state from a gas to a liquid, and freezing is a change of state from liquid to solid. A couple of laws, we'll talk about the law of conservation of mass and then the law of conservation of energy. And it's important to remember these two laws when we're talking about changes of state of matter. So the law of conservation of mass states that mass cannot be created nor destroyed. It is always conserved. The total mass is always the same before and after a reaction. Okay, so even though we are changing states of matter, the amount of mass does not change. We can simply just change its form, change its shape, and that's important to understand. Matter doesn't simply disappear, nor does it simply appear. The amount of matter in the natural world is consistent. What is not consistent is the phases or the states of matter that we can find it in. And the same thing is true for energy. So energy can be changed from one form to another during a chemical reaction. The total amount of energy does not change, just like with matter. So the amount of energy in the natural world is consistent. What's not consistent is the phases or the states of energy that we find it in. This is a law of conservation of energy. So that states that the amount of energy in the natural world is consistent. And the energy cannot be created nor destroyed. It can just simply change shape. And that'll be where we stop today. And if you have questions, please let me know. Go back and watch the video and let me know if you have questions over it. Thank you.